Good morning, dear student. In today's lecture, we will discuss the ring opening metathesis reaction. So, this ring opening metathesis, it is just opposite to ring closing metathesis. So, you should remember it is just opposite to capital RCM, that is ring closing metathesis reaction. It is just opposite to RCM, that is ring closing metathesis. Second point, the method, the ring opening metathesis is suitable for synthesizing the terminal dienes, for synthesis of terminal dienes. So synthesis. So this ring opening metathesis, it is useful or suitable for synthesis of terminal diene. Again, the important factor for this ring opening metathesis reaction is that the ring strain, that is strain in the ring strain favors, ring strain favor ROM, capital ROM, that is ring opening metathesis reaction. Again, the important point regarding to this ring opening metathesis is that here the selectivity is an issue. So selectivity is an issue. So we get E and Z isomer, and selectivity is an issue. And because of the formation, why the selectivity is the issue? Because the formation of a different crossmetathesis and self metathesis product So you should remember this point regarding to the ROM, that is ring opening metathesis. It is just opposite to ring closing. Again, it is suitable for synthesizing the terminal dienes. The ring strain favors the ring opening mechanism, ring opening metathesis reaction. Here the selectivity is an issue due to the formation of different cross metathesis and self metathesis product. Again, another important point is that only the unsubstituted bonds of cyclic alkenes are ring open, and it is, so you can write here, only the unsubstituted bond of cyclic alkene are open or ring open. Okay, for tri and tetra substituted cyclic alkene or larger ring size, we require more active Grubbs second generation catalyst. So only the unsubstituted bonds of cyclic alkenes are open with the help of Grubbs first generation catalyst. For tri and tetra substituted alkenes, we require Grubbs second generation catalyst. So let us discuss the another important points regarding to this ring opening metathesis. If you consider this ring opening metathesis, it is of two type. First, that is the cross metathesis with an acyclic alkene, that is, we can write it as a capital ROCM, a ring opening cross metathesis. And second, that is the ring opening metathesis polymerization. Ring opening metathesis polymerization. Metathesis polymerization. Ring opening metathesis polymerization. So we can write it is as capital ROMP. Ring opening metathesis polymerization. Again, if you see the important point regarding to the uh, this ring opening metathesis, then the substrate for this substrate, or we can say the system or the reactant in this ring opening metathesis substrate is generally uh, the norbornene and cyclobutane system. Norbornene and cyclobutane cyclobutene norbornene and cyclobutane system. For example, if we consider a substrate, then the norbornene. So we are very much familiar with this system. This is your norbornene system. COCl is there. COCl is there. So this is your norbornene, which having a high ring strain. Again, another is the cyclobutene. CS2 OAC is there. CS2 OAC is there. So this is your cyclobutene, norbornene, cyclobutene. Again, if you consider this system, that is your this case. Again, this is also your cyclobutene derivative. So this and this is also your cyclobutene derivative. Cyclobutene derivative. So these two are cyclobutene derivatives. This CS2 OAC, and this is, so this is your norbornene system, and this is your cyclobutene system. Again, another substrate for this ring opening metathesis reaction is the di-norbornene is also used. Di-norbornene is also used. This is your O is there. Oxygen is there. So this is your di-norbornene is also there. So these are the substrate for this ring opening metathesis. Generally, the ring strain, the system which having a ring strain is used for this ring opening metathesis. Norbornene, cyclobutene, di-norbornene, then benzvaline, it is also used. Benzvaline, it is also used. Then the tri-norbornene is also used. Tri-norbornene, it is also used. And again, if you consider norbornene with alkyne, so norbornene with alkyne is also used. So these are the substrate for this ring opening metathesis. Generally, you should remember the cyclobutane and norbornene system. So let us discuss the important type of this ring opening metathesis, that is cross metathesis. Ring opening cross metathesis. Ring opening cross metathesis. Ring opening cross metathesis. So if you consider this ring opening cross metathesis, this reaction is performed in higher dilution. So it performed higher dilution and excess and excess alpha olefin. So the condition for this ring opening cross metathesis is that the higher dilution and excess olefins to suppress the self metathesis reaction, to suppress the self metathesis product, self metathesis reaction, self metathesis reaction. So why use a higher dilution and excess olefins? To suppress the self metathesis reaction. For example, let us consider an example of this ring opening cross metathesis reaction. So if you consider 1 2 3 is there, okay, 4 is there, 5 is there, again 6 and 7 is also there. So this is your 7-membered ring system is there. A double bond is there between 1 and 2 carbon and 3 and 4 carbon. So this is your 7-membered diene. For example, this is your 7-membered diene. In presence of light H mu, it will shows 2+2 cycloaddition reaction. 2+2 cycloaddition reaction. So this bond will shift here, this bond will goes here. So what you get after 2+2 cycloaddition reaction in presence of light, we get this. The new bond is formed between carbon number 1 and 4. So we can write this as, so what you get here, we get this. So this is your carbon number 1, this is your carbon number 4, 2 and 3. The double bond is formed between carbon number 2 and 3, and the new bond is formed between carbon number 1 and 4. So we get a bicyclic compound, cyclobutane derivative, cyclobutene, not butane, cyclobutene derivative, which is highly strained, and this cyclobutene derivative, when react with excess alkenes, alpha olefins, in presence of Grubbs catalyst. So let us discuss the second reaction, that is the reaction of this bicyclic compound or cyclobutane derivative with double bond is there. So this is 1 2 3 4 5 and 6 carbon is there. So interaction again, excess olefin is there, and in presence of Grubbs catalyst is there, in presence of Grubbs catalyst is there, and it will shows 2+2 cycloaddition reaction. Again, we are very much familiar with this reaction. So we can write this as, we write this as plus, we can write this as double bond is there, total 6 carbon is there, 1 2 3 4 5 and 6 is there. So it will shows 2+2 cycloaddition reaction. So it will attack here, at the same time it will attack here. So what you get here, we get this. Again a new ring is formed, and here the substituent 1 2 3 4 5 and 6 is there, 6 carbon is that. Again we know that what is metathesis, the formation of bond between sp2 carbon which is not previously joined. So in this case the new bond is formed between this carbon and this carbon and this carbon and this carbon. So what you get here, this bond will goes here and this bond will be shift here. So what is the product, what you get here, we get this is your, okay, the ring is open, this is your, okay, here is double bond is there, here also double bond is there, and here the hexane 6 carbon is attached. So we get the final product. So this is your product, So you should remember this example, that is Initially we take 7 member diene. In presence of light it will shows 2 plus 2 cycloaddition reaction, and it will convert into bicyclic compound, that is cyclobutane derivative, which is highly strained. Again, high dilution and excess olefins are used to suppress the self metathesis product, and this bicyclic compound react with alpha olefins to give a ring opening metathesis reaction in presence of Grubbs catalyst, and it will show a ring opening metathesis reaction. So this is all about the ring opening metathesis reaction. In the next lecture we will discuss the remaining point regarding to this metathesis reaction. Thank you.